Good afternoon. I'm Mr. Rich. Thank you for joining me. We have a reaction here, a redox reaction we have to balance. It's a hypothetical reaction. We're not worrying about if it's a feasible or a valid reaction. We're utilizing it only for practice, and it's intentionally designed to be difficult. We have to balance this reaction in base. We have chromium oxide. We're not worrying too much about the valence states here in terms of nomenclature, but then we have permanganate and then giving rise to Cr2O7 and manganese oxide. You have to start here with oxidation states. If this right here is a -6, that's +6. All the items over here are neutral except for that second species, which is an ion. If this here is a -8, then that must be a +7. What about right there? We have a -14 because 7 times -2 is a -14. This had to be a +7 to neutralize it. Manganese oxide, this right here is a -4, then that must be a +4. Now we have all the oxidation states. We can determine what was oxidized. Anything that it has a loss of electrons is oxidized. Anything that has a gain in electrons, it is reduced. What is oxidized? Look at the metals here. Oxygen will stay exactly as is, -2. Chromium went from a +6 to a +7, therefore the positive charge went up, it's oxidized. Your oxidation half reaction is CrO3 giving rise to Cr2O7. What about manganese? It went from a +7 to a +4, it lost 3 positive charges, so it gained electrons and it was reduced. Here's your reduction half reaction, MnO4 minus, giving rise to MnO2. And now we've started. Look at each half reaction and then start balancing from the non-oxygen to the oxygen items. I have 2 over here. Now I have 6 oxygens and 7 oxygens. I'm going to add a water. But by adding water, I've brought 2 hydrogens. Remember, everything here is in a base solution, as you see right there. 2 hydrogens, I'll bring 2 hydrogen ions here. To balance those 2 hydrogen ions I've added, I must now bring in 2 OH minus. But to balance these 2 new items I brought, I must bring 2 OH minus here. Now this half reaction is completed except for the charge. I have a -2, I have a -2 plus 2, 0. I have a -2 here, therefore I must add 2 electrons here and everything will be balanced. The charges and the atoms are all balanced. 2 chromiums, 2 chromiums. 4 hydrogens, 4 hydrogens. 2 oxygens, 7 oxygens, 9 oxygens. 2 times 3, 6, 7, 8, 9, 9 oxygens. A -2, -2, and everything is good. Now let's look at the other half reaction, MnO4 minus, permanganate giving rise to manganese oxide. In terms of nomenclature, what I was alluding to earlier, I'm not giving you the proper nomenclature, but you could figure it out. We have a -4 here, we have a +4, so you're looking here at manganese 4 oxide is how you would say it. But the only way you can do the nomenclature is if you determine the oxidation states. Earlier I was calling that chromium oxide, but is it right? Not necessarily. You'd have to determine the oxidation state. I have a -3 times 2, -6 plus 6, so this would be chromium 6 oxide, because now you've determined the valence of that transition metal. That's how you do it. Here you'd have manganese 7 oxide. You can also call it permanganate. Anyhow, that's how you do it. You can imagine what this would be. Cr2O7, you have a -14, here you have +7 here you have chromium 7 oxide is how you would call it. That's how you go about naming these transition metals. You have to determine their oxidation states, or you can just say them out verbally, or just verbalize the chemical compound. Anyhow, let's get back to this. I have this giving rise to that. What's balanced? The manganese is balanced, the oxygen is not. I have 4 here, I have 2 here, therefore I can do 2H2O. Now I've generated 4 hydrogens here, I must bring 4 hydrogens here. But to neutralize these, I must bring 4 hydroxides. But to balance this, I must put here, in terms of the conservation of mass, conservation of charge, all of that, you bring the hydroxide on the other side. And now, is everything good? Well, maybe. You have to look at the charges. I have a 0 here, I have a -1 here, I have a -4 over here. Therefore, I must bring 3 electrons here and we should be good. And we'll check. 1 manganese, 4 oxygens plus 4, 8 oxygens. I have 2 plus 2 plus 4, that's 8 oxygens. I have 4 hydrogens, that's 8. Here I have 4 plus 4, that's 8. Now let's check the charges. I have a -4, I have a -1, -2, -3, -4, that's -4. I'm not counting these because these neutralize. Everything is good. Now what do? We have 3 here, 2 here. You have to multiply by coefficients to get rid of these electrons. I'll multiply this by 3. I'll multiply this by 2. And then we'll create a new set of reactions here, and then we'll cancel items out. When you multiply across, you have 6 hydroxides, you have 3 waters, you have 6 CrO3, 3 Cr2O7 plus 6H plus 6OH minus plus 6 electrons. Now we have to do the exact same for the second reaction. You can see how this is a little bit more involved. We have 6 electrons, we have 8 hydroxides, 2 times 4, 8 hydrogens. I have 2 permanganates, 2 of these manganese 4 oxides. I have 4 waters, and then I have 8 hydroxides. Now what we have to do is cancel things out, but before we cancel them out, we can do some quick modifications. The modifications we will do are these. You can combine all the hydrogens and hydroxides together. You see this? This is equal to 8 water molecules. You can just eliminate them and put 8 water molecules. You see this? This is equal to 6 water molecules, and I'll do exactly just that. I'll bring 6 water molecules over here. Remember, H plus and then OH minus gives you a water. Hence, I'm doing this. The electrons cancel out with that. I have here 6 hydroxides and 8 hydroxides. I'll cancel this out and I'll change this to a 2. It was an 8, here's a 6. I'm removing all of that and I'm bringing a 2 over there, and let's do that. Now we'll look at the water molecules. I have 11 over here, I have 10 over here. If I were to take these 10, remember they're on the right side, these are on the right side, and these here on the left side, 11 here, 10. I can erase all of these and I can minus them from the 11. So what you would end up seeing over here from all of these combined reaction is just a single water molecule would appear, and I'm putting that here, H2O, and they'll combine with everything here on the left side. All of this will have to be removed, and we'll remove it. What remains? I have all of these items remaining on this side, and I have all of these items remaining on this side. The electrons cancelled out, so I'm erasing them so it doesn't look messy. And that right there will be our resulting reaction, which I will put for you right over here, and we will be done. Then all that will have to be done is we make sure everything is good. Our final reaction will be this: water plus 6 CrO3 plus 2 MnO4 minus, giving rise to 3 Cr2O7 plus 2 manganese 4 oxides. I believe it's a 4 if I remember correctly, plus 2 OH minus. And that right there is our final reaction. We just have to check it out. To check it out, we just count everything. I have 6 chromiums, 6 chromiums, we're good. I have 2 manganese, we're good. I have a charge here of a -2, I have a charge here of a -2, we're good. Let's count the oxygens. I have 8 plus 18 plus 1. 8 plus 18 is a 26 plus 1. I have 27 oxygens. Here I have a 7 times 3, 21 oxygens, plus 4 plus 2, that's 27. And now let's count the hydrogens. 2 hydrogens, 2 hydrogens, and we're good. This entire reaction is good and it's balanced. Water plus 6 CrO3 plus 2 MnO4 minus, giving rise to 3 Cr2O7 plus 2 MnO2 plus 2 OH minus, and the reaction is balanced in base. And that brings us to the end of this video. Thank you.